Hi friend, myself is Chandra Kumar. I am taking electrical machine for mechanical engineering students. In continuation of the previous lecture, now we are discussing about the AC machines, which will be quite different from the machines which we already covered in the previous lecture. Previous lecture are totally based upon the DC machines. Over there, we are discussing about the construction features, their manufacturing, how we have to manufacture the machines, what are the different components are there, what are their applications and their operations are there. Now we are discussing all the AC machines construction features. The AC machine, there will be two types of machines are there. One will be the single phase machine and another is the three phase machine. And over here we are just discussing all the three phase induction machine, which is the most commonly used in the electrical parameter. Almost 80% of the mechanical power used by industry is provided by the three phase induction motor. Because of its simplicity and rushed construction, low cost, good operating characteristics, the absence of commutator, and good speed regulation, in three-phase induction motor, the power is transferred from stator to rotor winding through induction process. The induction motor is also called a asynchronous motor as it runs at a speed other than the synchronous speed. Three-phase induction motor construction, it will look like any other type of electrical motor, induction motor. A three-phase induction motor is constructed from two main parts, namely the rotor and stator. Stator, as its name indicates, stator is a stationary part of induction motor. A stator winding is placed in the stator of induction motor and the three-phase supply is given to it. Rotor, the rotating part of the motor, of the rotor is connected to the mechanical load through a shaft. The rotor of the three-phase induction motor are further classified into two categories. First one is the squirrel cage rotor. Second one is the slip ring rotor or wound rotor or phase wound rotor. Depending upon the type of rotor construction used, the three-phase induction motor are also classified as the squirrel cage type induction motor or slip ring type induction motor or wound induction motor or phase wound induction motor. The construction of a stator for both of the kinds of three-phase induction motor is identical and is discussed briefly. Please ensure you are using the appropriate electrical tools if you are going to be deconstructing a motor itself. The other parts of a three-phase induction motor are shaft of transmitting the torque to the load. This shaft is made up of steel, bearings of supporting the rotating shaft. One of the problems with electrical motor is the production of heat during its rotation. To overcome this problem, we need a fan for cooling purposes. For receiving external electrical connection, terminal box is needed. There is a small distance between rotor and stator, which usually varies from 0.4 mm to 4 mm. Such a distance is called the air gap. The stator of three-phase induction motor. The stator of the three-phase induction motor consists of three main parts. First is the stator frame. Second one is the stator core. Third one is the stator winding or the field winding. In the DC machines, we are using the word field winding, but over here we are just using the word stator winding because there is no excitation field. Or we can say that there is only a AC supply we are delivered to the stator of the machine. So we are not using a word field winding. It will develop a field, but the purpose, as we know in the DC machine, the purpose of the field winding to produce the field in a particular direction. But over here, the field winding is working as a both direction, not a but it's a bidirectional movement will be given for the by the field winding. This will be the stator. So it is the outer part of the three-phase induction motor. Its main function is to support the stator core and the field winding. It acts as a covering and it provides protection and mechanical strength to all the inner parts of the induction motor. The frame is either made up of die cast or fabricated steel. The frame of three-phase induction motor should be strong and rigid as the air gap length of three-phase induction motor is very small. Otherwise, the rotor will not remain concentric with the stator, which will give rise to an unbalanced magnetic pull within the machine. Naturally, with the stator core, the main function of the stator core is to carry the alternating flux. In order to reduce the eddy current loss, the stator core is laminated. These laminated types of structure are made up of stamping, which is about zero point 0.4 to zero point 0.5 mm thick. All the stamping are stamped together to form stator core, which is then housed in stator frame. The stamping is made up of silicon steel, which helps to reduce the hysteresis loss occurring within the motor. Naturally, the stator winding, the slots on the periphery of the stator core of the three-phase induction motor carry three-phase winding. We apply three-phase supply to this three-phase winding. The three phases of the winding are connected either in star or delta format, depending upon which type of starting method we are using. We start the squirrel cage motor mostly with star delta starter, and hence the stator of the squirrel cage motor is normally delta connected. We start the slip ring three-phase induction motor by inserting resistances. So the stator winding of the slip ring induction motor can be connected either in star or delta form. The winding wound on the stator of three-phase induction motor is also called as a field winding because it will helpful in developing the field within the machine. And when this winding is excited by three-phase AC supply, it produces a rotating magnetic field because the supply of the three-phase it's also a rotating in nature. So the developed magnetic field it also is a rotating magnetic field is there. Next will be the squirrel cage three-phase induction motor. The rotor of the squirrel cage three-phase induction motor is cylindrical and have slots on its fabric. The slots are not made parallel to each other but are bit skewed. Skewing is not shown in the figure of a squirrel cage induction motor beside, as the skewing prevents magnetic locking of stator and rotor teeth and makes the working of the motor more smooth and quicker. The squirrel cage rotor consists of aluminum, brass, or copper bars. These aluminum, brass, or copper bars are called rotor conductors and are placed in the slots on the periphery of the rotor. The rotor conductors are permanently sorted by the copper or aluminum rings or discs called the end rings. To provide mechanical strength, these rotor conductors are braced to the end ring and hence form a complete closed circuit resembling like a cage and hence got its name as squirrel cage induction motor. The squirrel cage rotor winding is made symmetrical in nature as end rings permanently sort the bars. The rotor resistance is quite small and it is not possible to add external resistance as the bars get permanently sorted. The absence of slip ring and brushes make the construction of a squirrel cage three-phase induction motor very small and robust and hence widely used three-phase induction motor. These motors have the advantages of adopting any number of pole pairs. The below diagram is shown as a squirrel cage induction motor having aluminum bars short-circuited by the aluminum end rings. There will be some advantages of the squirrel cage induction rotor. Its construction is very simple and rushed. As there are no brushes and slip rings, these motors require less maintenance. An application of this type of induction motor is we use the squirrel cage induction motors in lathe machines, drilling machines, fan, blower, printing machines, etc. Next will be the slip ring or wound rotor three-phase induction motor. In this type of three-phase induction motor, the rotor is wound for the same number of poles as that of the stator, but it has less number of slots and has fewer turns per phase of a heavier conductor. The rotor also carries star or delta winding similar to that of the stator winding. The rotor consists of number of slots and rotor winding are placed inside these slots. The three end terminals are connected together to form a star connection. As its name indicates, three-phase slip ring induction motor consists of slip rings connecting on the same shaft as that of the rotor. The three ends of three-phase induction winding are permanently connected to these slip rings. The external resistance can be easily connected through the brushes and slip ring and hence used for speed controlling and improving the starting torque of three-phase induction motor. The brushes are used to carry current to and from the rotor winding. These brushes are further connected to three-phase star-connected resistance. This will be the diagram of the three-phase slip ring type induction motor. Over here you are finding that they are the slip rings. It will be a shaft, there is a slip ring and the orange part will be indicated as a brushes and these are the resistances which will be connected externally for the machine. So all the three windings of the RYB are connected with the three brushes and these three brushes and the slip ring will be connected with this one. So we can adjust the rotor resistance by adjusting the rheostat of the stator side. At starting, the resistance is connected to the rotor circuit and is gradually cut out as the rotor pick up its speed. When the motor is running, the slip rings are sorted by connecting a metal collar, which connects all slip rings together and brushes are also removed. This reduces the wear and tear of the brushes. Due to the presence of slip rings and brushes, the rotor construction becomes somewhat complicated, therefore it is less used as compared to squirrel cage induction motor. There are some advantages of the slip ring induction motor. It has high starting torque and low starting current. Possibility of adding additional resistance to control the speed of the motor. Applications of slip ring induction motor are used where high starting torque is required, that is in hoists, trains, elevators, etc. These are the basic differences between the slip ring and the squirrel cage induction motor. On the basis of construction, slip ring construction is complicated due to presence of the slip ring and brushes. Squirrel cage is very simple. The rotor winding is similar to the stator winding in case of the slip ring. The rotor consists of rotor bars which are permanently sorted with the help of hand rings. In third one, we can easily add rotor resistance by using the slip ring and the brushes in slip ring type induction motor. Since the rotor bars are permanently sorted, it's not possible to add any external resistance in the squirrel cage. Due to presence of external resistance, high starting torque can be obtained. But in case of the squirrel cage, starting torque is low and cannot be improved. Slip ring and brushes are present in case of slip ring. Slip ring and brushes are absent in case of squirrel cage. Frequent maintenance is required due to presence of brushes. But in case of squirrel cage, less maintenance is required. The construction is complicated in case of slip ring, but the construction is simple and robust in case of squirrel cage induction motor. This motor is rarely used, only 10% industry uses slip ring type induction motor. Due to its simple construction and low cost, the squirrel cage induction motor is widely used in the industry. Rotor copper losses are high and hence less efficiency we are required from the slip ring type induction motor. Less rotor copper losses and hence high efficiency is there. Speed control by rotor resistance method is possible, but speed control by rotor resistance method is not possible in case of a squirrel cage. Slip ring induction motor are used where high starting torque is required, that is in hoist, cranes, elevators. But in case of the squirrel cage induction motor, is used in lathe machine, drilling machine, fan, blower printing machines, etc. So these are the differences between the squirrel cage induction type motor, where the two types of motor are there and their differences will be discussed in this lecture. Next lecture we are discussing about the more about the DC machine or the AC machine. Thank you.